Hey everyone! We've got some groundbreaking news from the cosmos, thanks to the incredible Gaia mission. Scientists have made a surprising discovery about the evolution of our galaxy, the Milky Way. They found a large number of ancient stars on orbits similar to our Sun's, suggesting that the Milky Way's thin disk formed much earlier than we previously thought, less than 1 billion years after the Big Bang. The Milky Way's structure. Our Milky Way galaxy has several components: a large halo, a central bulge and bar, a thick disk, and a thin disk. Most stars, including our 4.6 billion-year-old Sun, are in the thin disk, which follows an organized rotation around the galactic center. Until now, we believed this thin disk started forming around 8 to 10 billion years ago. Galactic archaeology. Understanding how the Milky Way was formed is a major goal of galactic archaeology. To do this, scientists create detailed maps of the galaxy, showing the ages, chemical compositions, and movements of stars. These maps are known as chronochemokinematical maps, and they help piece together the history of our galaxy. Creating these maps is challenging because it requires large data sets of stars with accurately known ages. The Gaia mission's role. An international team led by astronomers from the Leibniz Institute for Astrophysics Potsdam, AIP, used data from the European Space Agency, ESA, Gaia mission. They studied stars in the solar neighborhood, about 3,200 light-years around the Sun, and discovered a surprising number of very old stars in thin disk orbits. Most of these stars are older than 10 billion years, with some even older than 13 billion years. What this means? These ancient stars have a wide range of metal compositions. Some are very metal-poor, as expected, while others have twice the metal content of our much younger Sunday. This indicates rapid metal enrichment in the early phase of the Milky Way's evolution. Samir Nepal from AIP, the first author of the study, explains that these ancient stars suggest the Milky Way's thin disk formation began about 4 to 5 billion years earlier than we previously believed. This discovery aligns the Milky Way's disk formation timeline with those of high-redshift galaxies observed by the James Webb Space Telescope, JWST, and Atacama Large Millimeter Array, ALMA, radio telescope. Advanced techniques and future research. The team's results were made possible by the third data release of the Gaia mission. They analyzed the stellar parameters of more than 800,000 stars using a novel machine learning method. This method combines information from different data types to provide high-precision measurements of gravity, temperature, metal content, distances, kinematics, and the age of stars. In the future, similar machine learning techniques will be used to analyze millions of spectra collected by the formidable LR survey with the 4-meter multi-object spectroscopic telescope, FORMOST, which will start operations in 2025. Final thoughts. This discovery is a huge leap in our understanding of the Milky Way's evolution. It shows that our galaxy had intense star formation early on, leading to rapid metal enrichment in the inner regions and the formation of the thin disk. This new insight helps us understand how galaxies like ours evolve and grow over time. Stay tuned for more cosmic updates, and keep looking up at the stars.